Morning, everybody. I'm Gary Keenor, and I'm here this morning to do a live Ask Me Almost Anything for young people thinking about a career in rail. A few things before we start. First of all, this is the first time I've done anything like this. First time I've done a live stream. First time I've done Ask Me Anything. So hopefully you can hear me. If somebody could maybe in the chat give me a thumbs up that the audio is okay. That would be absolutely great. Second thing is I want a huge thanks to Lucy Pryor and Tracy Barber for setting this all up, and doubly so given the circumstances, the fact that we're all having to hastily shift to an online only way of doing it. So that's huge thanks to them for putting this all together. Anything that I say in this will be my views, not those of my employer. Standard caveat needs to be said. And the last thing probably is that before we get into it is that the purpose of today is to talk about STEM and really is for people who are interested in a career in rail, a career in maybe railway design, maybe a career in railway electrification. So that's the purpose of today. So maybe keep your questions about Series 1, why is third rail best, for another time. Okay, so I thought maybe the best way to start would be for me to just spend 5-10 minutes talking about what I do and what the people I work with do, railway designers, and then we'll just open it up to the chat from there onwards. So I'm just sorting out the audio for a second. Right. Okay, so for those of you who aren't in the railway industry, the railway industry is a huge variety of careers on offer. If you're outside the industry, what you'll be seeing is the kind of frontline staff. You'll be seeing the people who run stations, people who drive trains, people who dispatch trains, and they're all really important, particularly right now, obviously extremely important. But what you don't see is the army of people who are behind those people, who set up the systems and processes to allow those people to do their job. So there is a wide variety of careers in rail. It doesn't matter what kind of person you are, what your particular talents and skills are, there is somewhere in the industry for you. The part of the industry that I work in, we do railway design. So when you go out on a railway, everything that you see on the railway has had to be designed by somebody. It doesn't just come into being. You don't just go and build track. You don't just go and build a station. You have to design it first. So that's what people like me and my colleagues do. They design railways. So I work for Atkins, which is within the railway consultancy part of Atkins, and within there we have a large multidisciplinary team that can design every aspect of a railway. We can design stations, we can design track, we can design a signalling system that keeps trains apart and keeps you safe. We can design bridges, we can design tunnels, everything you can see on a railway. We can design the car parks, everything about that railway we can do. Now you might think, well, why does a railway need to be designed? The railway's already out there. With the exception of a couple of big projects, we're not generally building lots of railways. Well, the average lifespan of a railway is about 40 years. Some systems will last longer, but most of them last about 40 years. So what that means is that every year, Network Rail has to renew 1/40th of its railway. And when you renew a bit of a railway, you don't just renew like for like. You'll look at, if it hasn't been touched for 40 years, and you think, well, what does the day's traffic look like? It might be different train service patterns, might need more platforms. So you tend to upgrade the railway when you renew it. So that's where people like me and my colleagues will come in. Network Rail doesn't have a standing army of designers, because that wouldn't be very efficient for Network Rail. It would cost them a lot of money to have people doing that. So often Network Rail will come to companies like Atkins and other consultancies and ask us to do the design work on their behalf. And that's really what we do. Now, all of those different functions of the railway, there are very few people who can design all of them. It's generally not the case that you can design the track and the signalling and the bridges and the stations, because there's several lifetimes of learning to do to achieve that. So instead, what we have is teams who specialise in a particular field, and when we pull those people together to form multifunctional, multidisciplinary teams to deliver a project. So what that means is I'm an electrification engineer, so I work with the, let me just switch to main. I design a system that you can see on the main slide here, the overhead line that powers trains. But I'll be working on a typical project. I'll be working with the signalling engineers, I'll be working with track engineers, I'll be working with civil engineers, because the system I design impacts on the systems they're designing. It's a single railway, it's a single system, and the whole thing has to be put together to work together. So it's not a case of you just sitting on your own designing your system. You have to work with the others, because often the systems come into conflict with each other and you have to work out a balance between them. I should add, people like myself don't generally build, we don't then go on to build the system. We often get involved with supporting the people who are building it and helping them to understand why the design was done the way it was, the things they can and can't do on site. We don't generally get involved in the construction, but people like me move from design into construction and from construction into design quite regularly. So if you start in design, doesn't mean you can never go on to do construction. If you start in construction, doesn't mean you can't go on to do design. So that's probably, I'm going to switch to my big ugly mug. Hello. That's kind of an introduction to what I do. I'm going to pass over to any questions that you might have. If you've got any questions, stick them in the chat window and I'll try and answer them. But don't get any questions. I'm just going to rattle on, lose my voice, which isn't a good thing. So please do ask any questions that you have. Okay, so I can see from the chat you can hear me, which is a very good job, because I've been talking for the last 5 minutes. I suppose while we wait for some questions, I might just talk about a little bit about what makes a good railway design engineer. The people I work with tend to have a background in mechanical engineering, or electrical engineering, or civil engineering. Those are the three kind of big building blocks, and you can come into the area that I work in from any of those three routes, really. You know, a good solid foundation in maths and science is a good start, but it's not the only thing. You know, the ability, all engineers should have an ability to communicate, and you know, being able to communicate your ideas and your solutions is really important. So, you know, the ability to do that, to communicate what your ideas are, is really important. The other quality that tends to make a good rail engineer, in fact any good engineer really, is a desire to solve problems. You know, if you are a sort of person who wants to understand how a mechanism works, wants to, you know, takes things apart to understand how they work, tries to solve problems, maybe tries to put things together in a way that that other people haven't done, then that's a really good place to start. Our clients typically want us to solve problems that they might be struggling to solve themselves. So that's the desire to solve problems is really important. Okay, so we got a question from Track Teddy. Thank you very much. How much railway gets renewed each year, and how much of that is upgraded versus just renewed? That's a really good question. I think it depends on the system. All railway systems have the same lifespan. So if we take signalling, for instance, signalling tends to last around about 40 years. typically. So you will typically replace a signalling system around about every 40 years, and you won't renew it at that point. You're not going to renew it like for like, because the signalling technology of 40 years ago is very different to the signalling technology of today. So it tends to be a complete upgrade to modern standards of signalling. In the track world, track gets and Gareth Dennis I know is on today, so he'll talk much more about track. He knows much more about track than I do, but track renewal is really important because the track wears out. So track typically gets replaced every 40 years, but it obviously depends on the level of traffic. In my domain, overhead line, I'm doing some work at the moment, which is very interesting, actually, really looking at what do you need to replace and when on a particular overhead line system. For instance, the masts and foundations tend to have a design life of maybe 80 to 120 years. So we've got masts and foundations out there now which were installed in the 1930s, and they're still going absolutely fine with the occasional bit of TLC and a bit of painting. They're absolutely fine. The system, the parts that are in contact with the train, the overhead line itself, has a shorter lifespan, so that might last 40 to 50 years. Again, it depends on how much traffic you're getting. A lightly used line will last longer than a heavily used line. But before that, individual components may start to fail, and you may need to start going in and doing spot replacements on specific components where you're seeing an accelerated aging process. So I hope that's answered the question. Right, question about overhead line using aluminium contact wire. Now, this isn't an ask me anything about overhead line system, so I don't want to get too deep into that this morning, although we will do something this afternoon which is more in that space. This is just to explain. I have a piece here, and I'm probably going to break my camera's autofocus system trying to get it to focus on this rather than my face, but that is copper contact wire. So this is copper alloy. This is standard, used around the world. The reason for that is that copper is an excellent conductor of electricity, and if you alloy it, if you dope it with a small percentage of a different metal, you give it excellent mechanical strength and mechanical wear. However, if you join this up with something made of aluminium, between the interface between this copper and the aluminium, you get a thing called bimetallic corrosion, and depending on your atmospheric conditions, that can cause you significant corrosion problems. So there are occasions when we might use aluminium contact wire rather than copper and get rid of that bimetallic corrosion problem, and that's what the Chinese have used, and it's what we're now trialling and using in one location in the UK. And that's all I want to say about that. Okay. Let's think. What else can we talk about in terms of what I do? What are the qualities, I suppose, that makes a good engineer? I think you need to be quite analytical. You need to be able to be quite focused. The ability to see your task through to the end, and kind of, because our clients need us to hit deadlines, and quite often those deadlines are immovable. If they've booked a 4-day shutdown over Christmas to do the work that you're designing, then that's a deadline that's not going to move. So the ability to kind of focus and work with your colleagues and hit a deadline is really important. It can be in terms of workload, it can be quite peaky. So you tend to work on a project, and then we get towards a big deadline, and then everybody gets a bit under pressure, and then we hit the deadline, everybody relaxes a little bit, we kind of we have a cup of tea, and then we kind of start on the next task. So it's not kind of a constant steady level of effort. It tends to be a little bit like that. Okay, we've got another question from Tactelli, another really good one. How did you get into railway design? So I'll answer that on a personal level first, and then I'll talk about the second bit, which is really how should you try and get into railway design. So I went a very traditional route. I did went to school, got O levels, did A levels, then I did a degree. My degree was in electrical engineering, but with the job I do now, it could have equally been mechanical engineering. OLE is a hybrid discipline, so if you've got mechanical engineering, when you come in, we'll teach you the electrical side, and if you've got the mechanical, if you've got the electrical, we'll teach you the mechanical. I then joined British Rail on a graduate training scheme. So I joined them, and I did their graduate training scheme, and I kind of got put into electrification. Um, I didn't, at that point, didn't really know whether that was what I wanted to do, but I found it quite interesting, and I kind of stuck with it ever since. So I went a very traditional route, and that really, at the time that I joined the industry, there were really only two. There were two routes. There was you could join design as a graduate, or you could join construction as an apprentice. And those are the two routes in, but it's very different now. Now, I'd say you still need to study, get those, get good grades at school, particularly maths, science subjects. Um, English wouldn't do any harm either. The ability to write, the ability to talk about your ideas and present is useful. But we do. I'll be honest with you. We have people in Atkins who aren't good at presenting, who aren't good at those people-facing skills. That's not necessarily a barrier. Um, it is quite a neurodiverse industry, and you don't have to be the front man. You don't have to front up. I deal with clients, but some of my colleagues hardly ever deal with clients, and that's fine. They do things, and then I get to present what they've done on their behalf. So beyond school, the routes in really are obviously the degree route still exists. This degree route is still a good way in, and there are now, unlike when I was studying, there are now railway degrees. So you can still do a general engineering degree, or you could then go on to do a railway specific degree and go in that route. However, there are now design apprenticeships, and we have in my team in Swindon, we have two people who've come through the apprentice route, and they're really good. They're really good people doing really good work. So it's no longer the case that you have to have a degree to get into what I do, which is really really good, because a degree is one way in. It's quite a challenging way in, and these days it's frankly quite an expensive way in. So through our apprenticeships, we support our apprentices. We have a learning agreement, and we pay for their college studies, and that's a really good way in. So that's also, so degree or apprenticeship is a good way into design. The other way in is obviously to join another part of the railway, particularly construction, and then you could move in from construction into design. That's also a route that some people do. Right, let's just have a look, see what else we've got. I see Seb has joined us. Hello, Seb. Hope you're doing okay. I'll see you on the train at some point, hopefully in the not too distant future. Probably be a good idea while waiting for maybe some more questions to talk about what are the kind of challenges that what I'll tell you what I'll start with. What does a normal day look like for somebody doing my job? I think the first thing to say is that we are 95% working in an office, which is very lucky for us right now. It means that most people doing my job are quite happily doing their work from home, unlike our colleagues on the front line who've got a frankly far harder job keeping everything moving while keeping themselves safe at the same time. So my job and a designer's job is mostly office based. We'll spend a lot of time. Typically, you'd be doing CAD work, so we use 3D CAD natively. So again, if you're looking at what should I do to get skills for that, using a 3D CAD package doesn't have to be the one that we use. The one that we use is very expensive, and you won't probably have access to it. But get Google SketchUp or other packages are available, and pick up those and start learning how 3D CAD works. That's really important. So we'll do quite a lot of CAD work, but also quite a lot of calculations. So we'll use spreadsheets. So getting your Excel skills really good. Quite a lot of people don't really know how to use Excel fully. Using the analytical tools in Excel, something we do quite a lot, because we do a lot of calculations to work out whether what we're designing is safe and is going to perform as our clients need it to. And they'll be looking for us to demonstrate to them that that's the case. So quite a lot of CAD work, quite a lot of calculation work, some written work. Okay, we've got some questions coming in. Fenland soil moves around a lot. There have been problems with that. Yes, there have. I'm not going to talk about that here. If you want to pick that up this afternoon, I could talk a little bit about that. But yeah, as with all construction jobs, 80% of the difficulty is getting out of the ground, and it's quite hard. Soil mechanics is as much an art as it is a science. So in difficult ground, it can be hard to get that right. And in the 1980s, for a short section of the East Coast Main Line, we didn't get it right on that occasion. Okay, question. I also often hear it said that today railway staff are too siloed in their own disciplines. That's a good one. Thank you for that, Seb. And there is an element of truth in that. It's really easy, when you're in your own part of the industry, to kind of focus on that and not know what's going on outside of your little bit of the picture. I think I have to say, the things like social media are breaking that down. I mean, I know on this chat, I can see a timetable planner, I can see a train manager on the call. Social media is a really good way of breaking that down, and genuinely think that over the next few years, as people get more comfortable with using social media and the kind of do's and don'ts, that hopefully that'll improve it. But yeah, there is that problem does exist for sure. Which aspects of design, this is from Tom D, which aspects of design do the civil engineers lead within your rail team? So the civil engineers will typically look at, they'll be designing bridges, over bridges and under bridges. They'll be designing elements of stations. They will look at, for me particularly, if I needed a completely new overhead line structure of a type that's never been designed before, that isn't in the catalogue, then that's where they'll come in. Or we might just need an assembly or a wall bracket or a fixing or something like that. So we have a lot of interaction with our civil engineering colleagues, and we've got some civils people in Atkins who are very used to working with overhead lines, so they kind of know, although they're civil engineers, that they're also very capable electrification people at the same time. Okay, Seb, follow-up question from Seb about design, about siloing. How does this apply to design staff, and how can we break this pattern? It does apply in the design space. I think it's getting better, and really a lot of it is showing each other what you do. I think we do quite a lot in Atkins to try, and we have internal webinars. We have regular sessions where we will get an engineer to talk about what they do, what they're currently working on, an interesting project they're doing, and that's really important. So we try to encourage that. Okay, another question from Track Teddy. How easy is it to do something new in the railway which is seen as quite conservative? Yes. Let me just take a sip of water and I'll try and answer that one. It is certainly true that the railway has a reputation for being conservative, and to some extent that is a good thing. When you get on a train again, which you probably won't for a little while, but when you do get back on a train, you expect to get to your destination safely. Accidents on the railway are extremely rare events, and the reason for that is that over time we have learned what causes accidents and built rules in to prevent those accidents happening again. So there are a lot of rules and a lot of things that we need to abide by in order to design a railway safely. So those rules sometimes are necessarily conservative. Rules tend to be conservative. They tend not, sometimes you could break a rule in one situation, but but you don't know when you can break that rule. So it's certainly the case that we do have a lot of conservatism, but equally, our clients, want us to challenge that conservatism, and Atkins does quite a lot of work in that space to look at. We've got some very capable people, incredible people that I work with, who can really drill down back down to first principles and say, well, why does that rule exist? What actually is going to happen with this system if we use it like this? What would happen? We can model things, we can analyze things. So we do quite a lot of work, and I think our clients are increasingly welcoming us doing that. Yeah. Okay, I got a question from Anchor. Hello, Anchor. Nice to see you. We haven't chatted in a while. Uh, I'm sure Noel Dolphin must be very pleased with the Series 1 sign in the background. Well, I had to put something here to cover my ugly-looking printer. So yeah, Series 1. We're not going to talk about Series 1 this morning. That's the one that is absolutely out of bounds this morning. Okay, another question from Track Teddy. Do railway companies offer work experience to schools? Really good question. So, in normal times, absolutely yes. So and I can't speak for other companies. I know other companies do it, but I obviously don't have the specifics. But within Atkins, we have a work experience scheme, and we have relationships with local schools. So we have a relationship with a local school in Swindon, but also other schools around the area. And we typically have students, usually 14, 15-year-old students, who will come in and spend a week working with our designers and understanding what it is we do, and actually doing. We have some exercises for them, and it's based on some real designs that we've done, so they get a real hands-on experience of what it's like to do our job. Obviously, these aren't normal times. We're not doing that at the moment. Our office is almost closed. There are very few people working in our office, and I think as of yesterday, probably no people working in our office. Bit disappointing because actually my daughter was going to do a week's work experience in June. Obviously, we don't know if that's going to happen now. But once we get through this, once we get back to more normal times, then yes, we absolutely do that. And I would encourage anybody watching from other companies, if you don't have a scheme like that, absolutely do it. It's very worthwhile. Whenever we do it, we generally ask the students to present on how they found the week at the end of the week, and I think the engineers really enjoy doing that as well. It's good to get a bit of feedback on what you think of us as well. I suppose another thing that might be worth talking about is what do our clients look like, and what do they want from us? Well, um, typically our clients will have a typical scheme would be where a client, and it's often Network Rail, not always Network Rail. We have other clients as well. Will be looking to remodel a section of railway. So they'll have a piece of railway that maybe has essentially been fixed since the 1960s or 1970s or 1980s. Traffic levels have increased a lot since then. They may want to put in more platforms in a station. They may want to reconfigure. They might find that the junctions are meaning that trains are having to wait for other trains, and that's slowing the whole timetable down, and it's no longer giving them what they need. So they'll typically work up a remit, a scope for a project, and they'll come out to the market and say, right, well, we want to remodel this bit of railway. This is the functionality we want to achieve. This is how long we've got to do it. This is how much money we've got to do it. And can you assist in developing that scheme into a full design, a full detailed design with drawings that you can hand to people on site who can then get on and build it. So that's what we do. We tend to take a project from a conceptual stage through to a full set of approved for construction drawings that can then go and be built. And then we'll take that, we'll often then support that construction process. If it's a signalling scheme, we'll actually go and build it ourselves. Atkins does do signalling construction, but that's the only discipline that we do construction on. For the other disciplines, we would support the construction process if that's what our client needs. Right, another question. So we got a question from Gary Fox. Sorry, no, not from B Cook, who is a civil engineering student. Hello, welcome. How do I get into OLE design, or how did you get into it? Well, I got into it, as I said earlier, via a very traditional route. O-levels, A-levels degree, and then British Rail were doing summer placement training, and then offered me a place on their graduate scheme. But that's kind of irrelevant. That was too many years ago. Don't want to talk about how long ago that was. How would you get into overhead line design? Well, I think the first thing to do is have a really solid engineering foundation. So, get good maths and science grades at school. Get into some kind of either do A levels in maybe maths and science. That's one possibility, or do a college course in general engineering, or civil engineering, or mechanical engineering, or electrical engineering. The form of engineering at that stage doesn't matter too much. It's actually good to be quite broad. But in terms of getting into overhead line, once you've got an engineering qualification, or if you're on your way to getting an engineering qualification, the best way is to get on the company website. So Atkins has a careers website. The other companies also have their own careers websites. Get on, look for graduate and apprentice roles. Look for those roles. The apprenticeship scheme run at Atkins is great. It's a really good route in. We've got lots of people who come through that route and are now really, really solid, really great engineers doing great work. So that's kind of the way in from a design point of view. If you want to go in through the construction route, clearly companies like Network Rail and some of the other construction companies also have apprenticeship schemes that allow you to go in through the construction route. I hope that answers the question. If you're specifically looking at overhead line, we will welcome people with a civil engineering, a mechanical engineering, or an electrical engineering background. Our discipline is a weird hybrid discipline. There is no degree in overhead line. There's no course you can go on to do overhead line. I wish there was, but it's so niche that there isn't. So we will bring people in from wherever specialisation they're at, civil, mechanical, electrical, and then we will give you what you don't have. So you don't have to try and get everything. Clearly, mechanical engineering is a big part of it, but you'll be getting that through a civil engineering course anyway. The electrical side is a side that people tend to be weaker on and tend to be a bit nervous because it's scary and it's high voltage and it looks really horrible and dangerous. But we've got very good electrical engineers who you can learn from on that side of things. So hopefully that's answered your question there. Okay, see how we do with time. 35 minutes in. That's good. I'll wait for another maybe 5 to 10 minutes or so. If I wait longer than that, the camera battery's going to die on me again. And then we'll wrap it up once we've done that. While we're waiting for any more questions, this afternoon at 3 p.m. UK time, I'll be doing another live stream. The difference is that this afternoon what I'm going to do is run through an introduction to overhead line, how it all works. This is a little session that I run quite often within Atkins and also conferences and things like that, and it will be about an hour, maybe a little more if we have questions as we go along, and it will really give you an overview of the system both from an electrical and mechanical point of view, and hopefully give you a bit more of a flavour of the system and whether it's something that's of interest to you. Right, Anchor is asking, how would you compare one standard national system against multiple systems like Series 1, UKMS, etc.? Okay, I'll try and answer that in a general way. I'm not going to get into the specifics of UK systems because this isn't a session for overhead line engineers. There are lots and lots of different overhead line systems around the world, and that reflects two things really. One is when they were built. The oldest overhead line systems are coming up to 100 years old now. So it reflects the age they were built in and the technology and the materials that were available at the time. The other thing that they reflect is the particular requirements of that region, of that route, and of the traffic on that line. So clearly the overhead line in South Africa is going to be very differently specified to the overhead line in Switzerland, because the climate and the environment in those two countries is very, very different. So systems within countries and between countries do vary a lot. There is also an element, it has to be said, of national preference. You know, I always joke that if you get 80 OLE engineers in a room, that you'll get 80 different opinions on everything. There tends to be a lot of local custom and practice and local preference, and what the maintainers are used to and what the installers are used to, and to a certain extent what the people like me, the designers, are used to as well. So, you know, if you talk to a German overhead line engineer, they'll swear blind that stitched equipment is the best. And then if you talk to a Japanese engineer, they'll swear blind that compound equipment is the best and that stitched equipment isn't as good. So there's definitely an element of healthy debate and rivalry between different systems. Within the UK, we do have a very large number of overhead line systems. If you include all the sub-variants, all the little variations in tension and things like that, there are about 100 different overhead line systems in the UK. And actually, as an overhead line engineer, part of the challenge actually is understanding which system you're working with, what does that mean, how does it behave, what components can you use, what components can you not use. So it can be quite challenging. In recent years, we've tried to standardise on really 2 or 3 modern systems within the what's called the UK Master Series. And if you all I would say is, if you are out there and if you are working on an electrification scheme in the UK, I would encourage to work with UK Master Series. And if what you want isn't in there, then maybe talk to the people who own that system and see about getting what you want in there. That's the way it's designed to work. So that's all I'm going to say about that. This is a STEM event, but thank you, Anchor. That's a good question. Right, we've got a question here from Cotton Tree Rail, and I think this will probably be the last question I'll take, unless there are any STEM-related ones. Why are some overhead wires rigid bars these days, and is it really new? Right, in order to answer that, I'm going to first of all just talk about conventional overhead lines. So this is, I'll try and hold this up. Conventional overhead line is made up of these 2 wires. This is a catenary wire, so this is the top wire, and then this is the contact wire. This is the lower wire. And these 2 wires sit like that, and they have droppers. So this wire hangs off of this wire, and that's a conventional overhead line system. Usually 2 wires, sometimes 3, but usually 2. Right? So that's conventional overhead line. And the bottom, the thing that's in contact with the train, is this stuff here, this contact wire. And it's not really a wire, it's a solid bar. I mean, you can see here, if I do this, it's pretty solid. Right? I could not bend this if I tried. It's a bar. It's about 10mm diameter, solid copper bar. But when you hang it up in the air and you put a ton of tension on it or more, it behaves as though it's quite wobbly and quite elastic, and it will give and it will move around. That's conventional overhead line. The question relates to rigid bar, which unfortunately I don't have a piece of here. I do have a piece of rigid overhead line, but it's in the office, which we can't obviously go to at the moment, so I can't show you a piece of rigid bar. But it's an aluminium section. It almost looks like a track rail in some ways, but it actually holds a piece of contact wire in the bar, but it's a much larger, more rigid system. Why do we use it? We typically use it in tunnels. It's more expensive because it's heavier. It needs much more frequent support. So this stuff allows us to put our support structures 50 to 60 meters apart, which obviously reduces cost. Whereas a rigid system requires a support every 9 to 12 meters, which makes it, if you put it out in the open route, would make it very, very expensive. So we generally don't use it on open route. You don't need to use it on open route. This system performs really well on open route. However, in tunnels, you have a different set of constraints. You usually don't have a lot of room, and that's one of the chief reasons to use a rigid bar. The support arrangements take up less space, so you can fit it into that narrow space between the roof of the train and the top of the tunnel. The other reason is that this system has to be tensioned, so you have to tension this, and that means that there's quite a lot of mechanical energy in this system. So if this were to break, you are unleashing a lot of mechanical energy. Clearly, if you're in a tunnel, particularly tunnels which have stations, so Crossrail, for instance, which is being built, that does not use a conventional system, because if that system were to ever break, then it would put people at risk standing at the stations in the tunnels. So the beauty of the rigid system is it doesn't have any tension. So all of that tension, mechanical energy risk just melts away. So that's the main reason. Is it new? No. If there are a couple of people I can see on here who have worked with one of the rigid overhead system manufacturers, and they will tell you that it's certainly not new. It's existed for about 25 to 30 years, I think. So it's not new. It's got there's not that much of it installed around the world. There's a few hundred, a couple of thousand kilometers of it installed worldwide. So it's not new. It's well understood. Its performance is well understood. It's a solution for a particular problem. It's not something you would use everywhere. Okay, so we are 45 minutes in. I'm getting a bit dry in the throat, so if there are no more questions, thank you so much for joining me. Thank you for your questions. It's been a really, really good set of questions. I hope you found this useful. Thanks again to Tracy Barber and to Lucy Pryor for setting all of this up. And do follow the hashtags. There are lots of other things going on. Gareth Dennis is doing something today. I know some of the other, we've got train drivers, we've got train operators, we've got maintenance people, all sorts of people who do things that I barely understand, and I'll be tuning into some of those to see what it is that they do. So please do follow that. You can come back to my feed at 3 p.m. if you want to understand how overhead line works and maybe a bit more the technical side of things. Come back at 3. We'll run through a slide deck there. We've got some animations, a bit of video, and we can do a Q&A there as well. Okay. All right. Thank you very everybody. I'll see you later.